What's going on, guys? Today we're going to be talking about Einstein's theory of relativity, or I'm going to try to explain it. Essentially, the theory of relativity basically states that time is relative. And what that means is time moves differently for every object in the universe. So, an example would be if I was traveling in a rocket ship going super fast, let's say 99% the speed of light around Earth, okay? And I stayed up there for 1 year, okay? So I stayed in this rocket ship going near the speed of light for 1 year, circling Earth, and I came back down after what felt like a year for me. Down there on Earth, it would be 5 years, 10 years, 15 years in the future. The exact number, well, I haven't done the calculations. But you get what I'm saying. Time is relative. Time can dilate. Time works differently for everybody. So if you had two perfect watches, the watches could not fail, okay? And you gave one to the mother of a child and one to the child at the moment the child was born, you would find years into the future that those two watches are just barely different if they wore them on their wrists for their entire lives. Those, because time is relative and they experience time in different ways. It would just be barely different, but it would be different. So how do you come about this conclusion? Well, here's a really good example that Brian Cox came up with. I did not come up with this analogy. I did not come up with this example. I do come up with some good stuff, but this is real good. Okay, so let's imagine that my expo marker is a clock. And every time it moves 1 foot, that's a second, okay? And I move this expo marker at a constant speed. So if I do this, okay, it's when it moves a foot, then that's less time, right? But if I move it at a constant speed, and I'm always moving it at a constant speed, and every time it rises 1 foot up in the air, it drops back down, and each time I raise it a foot and drop it a foot, that counts as a second, okay? Got it? Now, let's say I do it like this. You can see it's going up and down. Now let's say I'm moving. So I'm doing this clock, and I'm moving across the screen, right? I'm doing the clock, and I'm moving across the screen. For me, the motion of my clock looks like this. For me, from my perspective, mine, okay? That's what it looks like, up and down. But from your perspective, it looks like this, okay? You pick up what I'm putting down, obviously, right? From your perspective, from the camera's perspective, when I move this thing, it looks like it's going in a triangle, but for me, I'm simply moving it up and down, okay? So, that brings us to the next step. Some really smart people have discovered that light travels at a constant speed. What I mean by light moving at a constant speed is that anywhere in the universe, no matter where you are, no matter how much air resistance you have, no matter how much anything trying to stop light is always going to move the same speed. So if I'm in a car traveling at the speed of light and I flip on the headlights, you will see nothing come out of the headlights because the car is moving at the speed of light and the light cannot go faster than that. So going back to our little clock here, light is coming off of this expo marker. It doesn't look like your traditional light, obviously, but there is light coming off it. Here we have white light, we have black light on the cap, and then we have black light in the middle, right? So light is coming off this expo marker and reaching your eyeballs on the screen, okay? So we've established that every time I move the clock 1 foot, that counts as a second, okay? Now, all normal. But from your perspective, every time...
I meant to say that from your perspective, every time the marker moves 1 foot, that counts as a second. From your perspective.
So here, it moves a foot, okay? Here, it moves a foot. Here, it moves a foot. Here, it moves a foot, okay? So we've got like 5 feet of motion from your perspective, but from my perspective, it's only 1 foot of motion. And you might be thinking, well, the clock still works because the time it takes to go from here to here is still the same amount of time as it takes to go from here to here. But you got to remember, the time doesn't exist really. Seconds, minutes don't exist in this hypothetical situation. The only time that exists is when this marker moves 1 foot, okay? And you also might be thinking, well, from my perspective, the marker's moving faster, right? From my perspective, the marker's moving faster. And you're right. The marker itself is physically moving faster. But here's the deal. The light coming from this marker is not. Because we've established that light speed is constant. So in basic physics, you learn that velocity times time equals a distance, right? If there's no acceleration. So let's just assume there's no acceleration because that's going to make things complicated. But we learned that velocity times time equals a distance. So here we have a constant velocity of light speed, so we don't have to worry about acceleration. And we have a certain distance that constitutes 1 second, right? So we have 1 foot. Once it moves 1 foot, that counts as a second. And the velocity is not changing. So we have 1 foot over, well, we'll just call the velocity 1. So if we move it 1 foot, that counts as 1 unit of time. If we move it 2 feet, it counts as 2 units of time, okay? So from your eyes, when this marker is moving 1 foot, that counts as a second for you. But for me, it only counts as 1/3 of a second because I haven't quite moved it as far. So with all that being said, if we count each one of these ticks as a second, there's 5 seconds going by from your perspective and only 1 second from my perspective. And that's basically the theory of relativity. So, yes, in the real world, this is not just an example. When I'm moving like this, time is going by a little faster for me than it is for you if you are actually here watching me demonstrate. And that is what's fascinating. Time travel is real. Time travel is possible. Now, we don't know if we can go back in time, but you can go forward in time. You can be a time traveler. It's possible. In fact, everyone is time travelers because everybody's clock works a little differently. If you want to look up more stuff about this, I'm definitely not an expert. And I'm basically just explaining this to help myself learn the subject more. So please let me know if I screwed something up. Please let me know anything I need to add. Yeah, so hopefully I did a good job. Bye-bye.